let's modify this slightly. So instead of returning, this will just be a void. It'll just be a little bit less typing. Void, void, and then console.write line that, and notice that this will also be console.write line and that. So now we aren't actually getting an answer back. Instead, all we need to do is just call this, and it will print out an answer. And we can even do something similar to this. Let's go ahead and just paste that there. And instead of putting answer there, this will be n1 plus n2. Close curly brace there, open curly brace, and n2 and n1. So that'll work fine. And let's see. Console write line, base compile value. I missed a quote. And so I put that there, and I'll go ahead and copy this there since it's the exact same line. So now we get the same, oops, I only did one number, so let me go ahead and go back to run again. So 42, 2, now I get 44. And if I run again, 42.05 and 2.123, now I get 44.173. So what I wanted to demonstrate is this will work if I do add nums and I say 4215, or add nums and I do 12.5 as a float and 8.7 as a float, and everything will work fine. In fact, I'm going to go ahead and comment all of this out because I don't need that. I'm just calling these methods. So if I run this, notice I'm getting the same value, and each one of these is used only once. If I want to duplicate this to handle, say, decimals, well, I just change this to a decimal and a decimal. And now when I actually call it, add nums, m, and then m. So remember that m there tells it that it's a decimal, and it automatically identifies up here which one it's calling. Notice that this has one usage, which is going to be that line there, and everything will work the exact same way. So this is the way that you can do method overloading in C# by just creating multiple copies. In C++, you can do the same thing, but what you would end up doing to try to avoid creating multiple copies of the same method is you would template this to where you would have a templated type here and a templated type there. So whenever you call it, you would do like int, for example. Now there is kind of a way you can do that in C#, and we'll talk about that next week when we get to generics, but it's a little bit harder to do in C# just because of the protections that C# implements to save you from yourself.